Salutations from the stars! 'Tis I, the eccentric Professor Copperstein, and I'm here with lesson 2 of my Arduino lessons. Arduino lessons video 2. Lesson 2 of my lessons, yes. Well, anyway, so last time I said that my next lesson, which is this one, is going to be about analog and digital signals. And I was right. Of course I'm right, I planned it. Okay, well, and if you may have seen on the video, I said that I was gonna include a link to the original site. I said I would, but I don't think I did. But it will be up as soon as I am about to post this one. So don't despair. It should be back very well. It should be back very soon. Anyway, let's go on with the lesson. And now, one thing you will know about the Arduino. I mentioned it has pins, and everyone should know it has pins. If not, you're living under a rock. So, look at this. Notice how some of these have like a squiggly line. And the analog pins are there too. Why are they there? Oh, well, that's what I'm about to tell you. You see, circuitry works on electricity, as we all should know, but however, what we always say is that computers have a language. And yes, that's right. A language that is based on numbers. You see, computers, they don't speak "Hola, ¿cómo estás?" They don't say "Kapla." They don't say "Gondag." No, they don't speak human languages, or in one case, the one alien language I said. They speak a numeric language called binary. Binary is, well, it consists of 2 digits, zeros and ones. Yes, this is the on. However, that's where the signals that we generate go into the play. You see, 0 and 1, as I described, are off and on. That's 0, 0, 1, no, yes, off, on, inactive, active. You see, that's like a it's like a two-sided topsy-turvy way of viewing it. But that's the digital way. There's also analog, which can go between. Allow me to visually demonstrate. Okay, so as we can see here, we have a graph here. Okay, so this is time, and we can measure this as as I for current. Now, take a look at this. Assuming this spot to be 1, and this to be the origin, so obviously it's 0. Here's what. Let me use a green marker to represent what a digital signal would look like. So there. So you notice that it's either 1 and skips straight to 0, then skips straight back to 1. That's basically how a digital current works. It's either on or it's off. Remember the previous video I made? The button, or in my case, the button. Yeah, so basically that's how buttons work. If you press the button and it's active, then you release it, it's inactive. So now take a look at this. I'm going to use a blue line to represent an analog signal. See? It's like a wavy line. It looks like a sine wave. Of course, it's not a sine wave. Now, as we can see, I as digital, current as digital, can result in a value. 0 is less than or equal to I is less than or equal to. Wait, no, that's analog. See, that's analog, whereas I can't write right now. Whereas in the digital sense, I is equal to 0 or I is equal to 1. So you see the domains are different. Analog is between, but digital can only be one or the other. So luckily the Arduino has a way of sensing and even distributing analog or digital. So we already know that the Arduino can sense and distribute digital via buttons, the digital write function, the digital read. But as for the analog pins, well, it also has its own way of sensing and distributing them. Now, let me first talk to you about distributing. Actually, no, sensing first. Okay, sensing. Let's talk to you about sensing analog signals. Now, we've seen that this is what the analog signal would look like. That being said, it senses this type of analog and it interpolates between 1 and 0. The computer inside the microcontroller interpolates analog signal and produces it signal between 0 and 1023. Okay? So you see, this is what is going on when the Arduino is sensing a analog signal. This is delicious soup. And so the computer, as we said, distributes this one, and then using this value, you can further make another interpolation via a function I want to teach you called map. Yes, that's the name of the function, map, and then say variable x. Let's say that you have the analog signal here, and then you want to interpolate. You can. Okay, so x1, the lower x values, and the higher x value, and then the lower y value, the result of being the results, and then the higher y value. That's not 1/2. That's y. That's y of 2. So there. That's the syntax of the map function. You have the variable that you want to interpolate, the lower value and the higher value of those variables. Sometimes they can be 0 and 1023. That is if you're using an analog signal. And then y1 and y2 are the upper and lower values between which you want to interpolate between. That being said, we can have a y, and then y1, yes, and times y2 minus y1, and then There. So there we have it. That's the interpolation equation. This is what the map function works on. So let's see it in, so that's basically sensing it. So, but here's the next part. What about distributing an analog signal? See, because sensing it, that's where the analog pin comes from. Pin A0 all the way to A5, that is for Arduino Uno. There are other circuit boards of Arduino, such as the Arduino Mega, which has a whole bunch of them. Arduino Mega is Arduino Uno on steroids. Of course, minus the bad testosterone problem and rude behavior. And yeah. And so, what about distributing them? It has that too, because these analog pins, they only sense, but they don't distribute analog sense. And so what you have instead is that some of the digital pins will have like this squiggly line, like that. That's where we have something called PWM, pulse width modulation. Now, pulse width modulation, let's erase this for a moment. I hope you took notes. That is if you want to learn this. You really don't have to on that thing. Okay. Oh, shit. Well, there goes the graph. I'll just redraw that x-axis. Okay. Okay, so again, this being x-axis being time, obviously, and that's a 1, obviously. Now let's draw a dotted line. That being said, let's bring this to 90 degrees. I love this ruler. Increments. There we go. Let that, yeah. Okay, now, say that we were to get whatever interpolation we get from that equation we have here. Now, let's apply that to the voltage given. The voltage is also interpolated through this use, but it does that in the computer. Now, when it comes to how long this works, the PWM, the pulse width modulation, what it does is that it gets this, it gets the voltage, and then it actually turns it off and back on for a specific amount of time. You see, these little increments, those are an infinitesimally small amount of time, and the voltage is on for a percentage of the time. You get it? So let's say that between 1 and 0, that we're given a percent. We're giving like 0.8 of that increment. So we can draw like this here. That's me eyeballing it. So let's say that right here, that's 0.8 in relation to the increment, aka that means that the signal is on for only 80% of the time. This is called a duty cycle. D-U-T-Y-C-Y-C-L-E. Duty cycle. Now, the duty cycle is basically how much percent of the increment that it's on. It can be 80% of the time on. It can be 70% of the time on. This is what pulse width modulation is. That's how the Arduino distributes an analog signal. You see? That being said, let's have let's do this on the Arduino and code it out. I got some things I want to teach you. Okay, so I went to the Liberty and I actually built the circuit already, because now that you know the basic components. Now, so one thing you should know about Arduino is that it's no different from, well, it stems from C++, or some C language, we're not sure yet, but it has all the same features, and in there's a hashtag include in C++, and Arduino is no stranger to that. So this, I want to show you this here. Hashtag include. Now normally you'd see an IO stream in C++, but in here in Arduino, hashtag include is to include something called a library. Now I'm going to include one specific library that we're going to use today. Servo. Now this servo library is the library used for, well, obviously, servos, which can be used in armatures. You will see them a lot in robots, and they're mostly like swiveling from 180 degrees, and and also end them in .h. That's their file extension. Okay, so immediately after this, we can name it. On this point, I'm going to name it Swivel. I like to do that. Okay, and end it with the semicolon. Now this line you don't have to end with a semicolon. So, okay, so first off we have the servo. That's one thing. Now, of course, obviously we're gonna need wires and resistors. And this one we're also gonna be working with a potentiometer. Now, a potentiometer is a resistor. Well, specifically it's called a variable resistor. And the way it works is that when you change its configuration, such as like twisting a knob on it, depending on how it's built, if you change its configuration, it actually affects the resistance. Using Ohm's law, that is V over IR, no, V equals IR. If you rearrange that, you get R, piece of shit. R equals V over I. So you see, resistance has an inverse relationship with the current, and so when the current goes up, well, remember the Arduino uses 5 volts, so the voltage is a constant at this point. The resistance goes up, the current goes down. Resistance goes down, current goes up. So that's what I wanted to show you guys. So next, of course, then capacitors. I've already shown you in the video, and of course the button from the last video. Those are the components we need. Yeah, this is the reason I use these type of comments. Yeah, as I said earlier, comments are like your notes. Okay, so let's begin. Now I have assigned a few variables of my own. If I can see them. Let me get a. Ah, shit. Okay, 2. Okay, 2. Constant integer button equals 2. Now there's more. It's not the only one. Oh yes, I also have an integer. Let's see what the potentiometer. Let's name it pot. No, this is not marijuana. This is not marijuana. A0. Now, A means analog pin. This is the pin we're gonna use to sense the analog signal. sensor picking up analog signal. So we have one sensor and we have one digital sensor. And then there's also the actual swivel itself, this one. We have a name already, but we haven't assigned a pin to it. So to assign a pin, let's go to the void setup. Ah, shit. Curly bracket. Now we have swivel. That's what we named it. In this function, dot attach. In this case, I picked 5. Now 5 on the Arduino Uno is one of the PWM pins we've got going on here. So what's this? My gosh. Okay, I'm sorry, things are going on around here. Okay. So now we've already got the constants, and so let's also declare variables. It's called an for the analog signal, digital input for the button, and actually let's not assign a variable to it yet. Let's just declare it before we have the void setup. Analog signal in parentheses 0 to 1023. And then integer die. Digital signal. 1 or 0 or 1. Okay, so we got that. We have already established the pin, and so let's go ahead and get the loop. Okay, now, oh yes, one more thing. Constant integer light equals 13. Built-in LED. Now here, I was actually going to talk to you about it, but I just forgot, like right now. There's actually an easier way to include a library where you can just sketch, and then include library, and look, you have all the libraries right here: Bridge, EEPROM, Explora, Ethernet, mouse, liquid crystal, robot control, robot IR remote, robot motor. You got everything here. Wi-Fi, SD, you got it all. Now, of course, some have to be downloaded. You can get them from the link to the site. I'll include a link to the site in the description below. And so, okay, so let's get started on the loop. You see, die. We've already declared die, so we don't have to declare it again. See, when you declare it here before the setup and loop, it ends up transferring to the setup and the loop. So you won't have to declare it over again. So die is going to be equal to digital read the button. There we go. And so, and the analog signal is going to be equal to analog read. So there you go. You have digital read and you have analog read. Analog read pot. The potentiometer. Don't think of marijuana right now. You might have munchies, but okay. So now for this part, since n is equal to either 0 or 1023, we will have to do interpolation. So remember what I told you like earlier in this video. I hope you took notes. Let's call it ang for angle. Oh, and let's declare it. Yeah, we didn't declare it earlier, so we have to declare it now. So, and only in the loop. We don't have to declare in the setup. So ang is equal to map and 0 1023 20 359. Now look at this. All numbers, all range of numbers start with 0. So, wait. I just remembered. The server only goes to 180, so 179. Yeah, not 300. Yeah, don't. Yeah, this mine doesn't go all the way around. It goes only 180. So just be careful. I almost made a mistake. So obviously, ang is angle in degrees. So here we are in the digital loop, the void loop, and so let's have the computer digital write light die. So if the button measures on, the light's gonna turn on. If it's off, it's gonna turn off. Now this time there is no analog write here, not this time. So instead, since this is servo, we have instead this function, swivel dot write. Now notice that the W is lowercase, whereas this one is capitalized. So write on the swivel, ang. Remember, don't put an. An is the analog read from the potentiometer. Ang is the angle in degrees. So there we go. This moves it, and so I'm going to upload. Compiling the sketch. It's uploading. Okay. Okay, so here's some other thing I want to talk to you about. This is a neat tool I have here called the serial monitor. Now, the serial monitor is used to monitor electrical components. So, okay, so I'm actually modifying the sketch right now. Okay, serial begin now. The begin is what is called a baud. How many bits per second? The standard is 9600, so you always want to start with a serial begin with a baud of 9600. So, okay, void loop. Now here's something. Here's something that makes this very interesting. Okay, so first of all, okay, I better do this quick then. An equals analog read pot. And so here we go. We can start off with serial print and then quotation marks. Pot reads and space. We can close that. And serial now print is when you want to show there. Now, when you want it to read in alphanumeric, have quotation marks. If you want to present a variable, ditch the quotation marks. And Okay, and oh, and also you want this to present a new line, so add ln. That way, it once it's done presenting an, it stops it and skips and reads it to a new line. Okay, so let's show what we get. Let's see what we got here. Okay, uploading. Now you can open it through this button, or you can press Control Shift and M. Ooh, okay. I don't know if it reads, if you can see it here. I really hope you can, because I'm seeing a lot of cool. I'm seeing a lot of buttons here. Okay, so you see that is how analog and digital works. That's the main difference between them, and I hope you now understand how to use these two. So how to use them. So yeah, I'd show you my servo, but for some reason my servo doesn't want to work. I have the whole circuit right here. Actually, that's my servo. I plugged it in and it just doesn't want to work. I think it's a problem with the servo because I use this stereo monitor and the Arduino is working. It's just a servo. Well, if I'll probably fix it, or I'll probably just get a new one. But anyway, thank you for watching. Make sure to subscribe. Check out my other videos. Like and subscribe. Do also stay tuned, because sometime maybe in May, I'm actually planning a virtual party. So I hope you could follow me on Twitter. So thank you for watching. I am Professor Copperstein, and signing off.